Okay, the vile vortices, 12 of them, discovered by a guy called Ivan T. Sanderson. Something show magnetic variances on lands, like this one, but then there's other ones that will show you magnetic variances at sea. And up at the top of the Asia, top left there, is the devil or dragon's triangle. To the right of South America is the South Atlantic anomaly. In the middle there is Bermuda Triangle, but these do extend, these are longer, so the one in the middle between the Americas should elongate up towards the pole a little bit longer, and that's what happened with Titanic. Titanic thought they were 200 miles east of where they actually were, and that's why they hit our iceberg, because of magnetic variation. But these spots here are all symmetrical. 5 on the Tropic of Cancer and 5 on the Tropic of Capricorn. And in all my videos I always try to explain that the North Pole and the Earth's actual magnetic pole I've always thought that the Earth magnetic pole hasn't moved, but it's not where we last said it was. And this moving thing as well, I'm pretty sure they'll probably combine it with magnetic variation to give a different location. But the map that we use at the moment, if you combine that with a magnetic map based off the magnetic equator, then you'd have, even if you just used what we've got at the moment, the magnetic north and magnetic south, but all these spots here would show up in gaps between the two grids, and in simple terms, the magnetic map would show that there's a smaller equator. Why is that? It'd probably look better on paper. I need to get some drawings done and stuff. I've done loads of stuff on it, and on a flat earth maps I had these sort of grid references here, these sort of shapes, these star shapes on flat earth maps that I made. And you need to look at all my videos, flat earth videos, where I show that on a flat earth map you have very obvious places that have these voids are triangles, and if you look at these pictures here, they're not triangles, they're squares or rhombuses, whatever. But in my flat earth map you'll see that they're triangles, and there's easy to make the Pacific look bigger than what it is. Why do that? Because circumpolar wise, if it's 40,000 and it turns out the equator was 36,000, well, not you wouldn't have a sphere. Well, you would have a sphere, you would have a spheroid, but you wouldn't have a ball, and it changes the whole dynamics of the story and what we prefer to believe. But yeah, look into vile vortices, possibly here. I think I looked at this picture, this was probably about 2 years ago. I looked at this picture and I started to draw lines between all reference points on my flat earth maps that I made, all in videos. I can answer pretty much any question, I reckon, about a flat earth map and how you can get down to 25,000 kilometer diameter. One thing you can ask yourself is, well, what 2 points are from north to south are more than 25,000 kilometers? And if you say, well, South America touches Antarctica, it's very possible, and also if the meter is based on the circumpolar, then you can't use it equator wise if the equator is 36,000. So you have to redefine the meter. But a natural thing that would have happened anyway, but for the right reasons, but not realizing the circumstances that would come from changing that. So with 36,000, could you say an average would be 38,000? But then when you start to do that math, then you can easily, you can easily say that the meter is not a meter in Earth terms. So var vortices, yeah, great stuff. But look into 10 different entries, because when you start, as soon as you look at something 10 times, maybe 20 times, 20 different things, if one anomaly shows up, then it's got a chance. So that chance you look at and you look into and you look hard, and then you start to discover great stuff. Like here, where the var vortices are, where they look different in different maps. But definitely something in conjunction with ley lines. But yeah, triangulating the world. Now the other interesting thing is if I've got this correct in the way that I've understood it, we came up with the Anglo-French survey in 1790s, and they were able to accurately measure what a triangle area of something was, and then work out triangulation experiments so that we could work out the area of our land masses. Pretty sure Siberia wasn't accessible, but still, we got that sorted. And pretty, obviously this is an inflated map. Yeah, this is a way inflated map, because even something like Asia, Eurasia is 56 million kilometers squared, and Africa is 30. So double the size, maybe, but it looks inflated. So am I right in saying that if you look at this map, the size of the triangles is what's different? It's not the map. The map is a completely flat map. It's the size of the triangles that are used in different parts of the map make it look something that it's not. So the other thing is, by knowing how to measure triangles on flat, we haven't accounted for curvature. Or have we accounted for curvature by using small triangles or different sizes of triangles? Possibly. I'd like to know your thoughts. But even something like this in 1983, yes, I know, it's a bit of a late system, but isohedron projection, Mercator. So Mercator being at least 800 million kilometers squared. But if we haven't accounted for curvature in these measurements here to work out what an area is, then easily we've lost 10% of the actual distances, or the scale is wrong, because the scale has to account for curvature. Try to work out the area of two flat maps with a width of, well, there'll be flat maps, that would have to be 12,750. 12,750 times, let's start, divide by 2, times 6375 times pi. So two flat maps would have to be half. That's a lot of inflating to do, but I think on the curvature and calculations, 10% It works out to something like 10%, doing bits of maths. So yeah.